I will say, because this will come into the talk a bit, in addition to my primary job, I do teach at Washington University in their kind of between their computer science and analytics. So that becomes an important recruiting avenue for us. Actually, two of my former students are even in this very audience. Also have the YouTube channel with 77,000 subscribers and growing. Really did not plan on doing that, but started putting my my course material up. So first of all, just about RGA. First of all, we're probably not really going to sell you anything unless you're looking to sell a block of 100 million or so in life insurance. We're a reinsurer, so we take. There's direct writers. You've actually heard from a number of them in the keynotes, where companies like MetLife, Northwest Mutual, others will take these very large blocks of business and then move them potentially to RGA or on a policy by policy basis. So that's where a lot of the models that my team gets into production, works with, are really designed to do, is to assess risk without having to do blood samples and saliva tests, all these very invasive sort of procedures that you normally have to deal with when you're buying life insurance. I remember my parents getting life insurance, and the agent came in and sat down at the kitchen table, and I'm a bit dubious to let any sort of agent actually into my house because they're not gonna leave until they get something. So we are fortunate 222nd. That was the position as of last year, and then 3,800 employees. We're very efficient with the number of employees that we have for our rank. We do a lot of automation and other tools that my team and others help to do. We're in 6 continents and 100 countries, so we're a very global company. So this talk, what I am discussing is the interaction between IT and data science at RGA, and we'll get into some definitions of what I mean by that as well. Domino has been a part of RGA for about 4 years now, and they originally, given some of the corners that they helped us smooth out, Domino suggested the idea for this talk, and we'll get into that. So first of all, what is data science? For a while, I would get questions of my job title. Are you a data scientist? Are you an information scientist? Are you a computer scientist? I've been doing this for 25 years now. So if I had to write my job title kind of as a regular expression, that's probably where I would put it. Data, decision, software, computer for the first word, and analyst, scientist, engineer for the next one. Now, some of them don't really go that well together, like computer analyst. I don't know, maybe that's marketers have put these together in just about every combination. But I did actually ask ChatGPT to write it where the different ands and ors fit together like I actually planned. I've never been called a decision engineer. But so how I am defining data science, particularly in this case, is the way that somebody coming out of one of the degree granting programs, such as WashU, where I teach at in St. Louis, they're going to learn a lot about statistics. They're going to learn a lot about Python programming, maybe R programming, depending on where they're at there. They're not going to learn a lot about Docker images, dealing with maybe creating a RESTful API to deploy a model to the cloud. They probably don't have a lot of idea of what it takes to support a production system Where like at RGA, we have sort of 3 levels. We have dev, where anything goes; stage, where you're trying to, where you're testing it out, the users are looking at it. And then finally, okay, speak now or forever hold your peace, because now it's being promoted to production. So these are some of the differences in how IT kind of looks at some of these things, and how the more analytics people look at it. And at RGA, we have a variety of analytics people. And we'll get into that in a moment. We've got actuaries, we've got data scientists, we've got statisticians, we've got even quants in various fields. So just talking about how we interact between those. So data science and IT. First of all, like the keynote that we just got out of, I use generative AI to create all of my clip art. It makes it really easy to clear through the corporate communications group at RGA, although it's an open question if AI can be truly creative, if that does violate a copyright. But I was thinking like shadow IT. So I was thinking, yeah, create me a generative. And I'm like, what is the ultimate shadow? Because I used to be in IT. I was in IT for the first 12 years. So when I shadow IT, what's the ultimate shadow? An eclipse of the sun. So I had it create basically an eclipse of the sun for on a laptop. It's always interesting to see the strange language that it puts onto the actual keys. So one thing that we've always talked about at RGA is shadow IT, and then just dealing with limited sort of IT resources. Like one thought process that I've often heard is we'll try to get access to a lower level, to like a database. We need access to the data. We want actually to connect to the database directly in Python, this sort of thing. A common pushback in compliance is we should never have end users actually accessing databases at that low of a level. So those are two ends of the opposite sort of spectrum of thought there. If we had unlimited time, we had unlimited IT resources to throw at it, you should never have a user maybe access a database directly, because you could build whatever sort of front ends and other things around it. Now, the reality is they'd probably have you go build Tableau and DB Visualizer on top of it, so that it ends up being the same thing. But in a lot of these cases, by empowering the end users, we can get around some of the time that it would often take to get to these, but then getting the governance in there is the tricky part as well, which I'll talk about some aspects of that in a moment. So I think one of the challenges where you've got a company like RGA, where you have a definite IT group, and then you have other analytics users, but all access sort of to compute has to go through the IT group. The concept of the analytics users becomes tricky, because they are coding now. We have all sorts of actuaries, life insurance companies. So an actuary is somewhere between a statistician and a finance sort of person. Their tool of choice very, very often is something like Microsoft Excel, where you can basically use VBA to code a lot of these things, doing some of the same things we were doing in Python. But now the Society of Actuaries actually has R. I don't completely agree with the choice of language there in all cases, but they do have R as a part of the exam that you take to earn that actuarial credential. So now you've got actuaries, instead of using VBA to do a lot of the same sorts of things with the types of models that they were interacting with, now they can do this in R, and many do it in Python as well. And now you start to really get into that shadow IT sort of area, because now you are installing Python onto local computers. You're installing package libraries that, if they don't have vulnerabilities the day that you install them, they will tomorrow. And you're then in that sort of you're very much in where IT would see as classic software development. And then you start to get into in further escalation where maybe multiple users are using things at the same time. We run into some issues with Excel there. So we've got the actuaries, and then we've also got software engineers. So software engineers are using the analytics products themselves as well, because there's all these MOOCs out there, and you can take that and you can learn basically how to create predictive models. And we have software engineers then that become sort of, although I just heard from in the keynote from Domino, from Nick Alperin, that the citizen data scientist is dead. I don't think that's definitely the case we're at RGA, but we do have software engineers now as citizen data scientists. So they may not be as schooled in some of the statistics, correlation, causation, how to figure out the difference, which of the more classic statistics models you would use for various types of things, but they're really strong on getting something, say, into production or building a pipeline around it. And then we've also got, we have quants now. Because we're a financial institution, and we are actually executing trades from institutional brokers, and we certainly want to optimize that as much as we can. Now, probably not doing that at the level of some of the institutions on this particular island that I am standing on right now of Manhattan, but we do particularly in fixed income and derivative type investments. We do have a variety of strategies that we are using quantitative finance on. We have a global IT organization, so we have an overall IT group that has control of all production systems. So that lets us put something like Domino into the middle of that, which Domino is now a production system. But inside of Domino, you've got Docker images, you've got all these kind of things in a very controlled environment, and that has worked out well for us. Where we also run into some areas where we've run into some problems where we have shadow IT users becoming more and more advanced, where there's a lot of tools now, like Streamlit and Shiny if you're in the R space, or Flask if you just want to kind of go for broke and write it from scratch, where these small dashboards and other things that the more traditional analytics users have put together now start to develop multi-user characteristics, transactional, like ACID type transactions, where you want to update one part of it, but if the whole transaction has to fail together, all the CRUD operations, create, update, delete, you start to then move into traditional software engineering. And we had a very transactional, traditional sort of update and controlling users and multiple levels of access written entirely in Shiny R. And that reached a certain level where it became very difficult to support it as a full-blown application where you're managing users and potentially background tasks and other things there. So when that user interface comes in, that can be, Streamlit and other things do make that easier. But when you have data scientists starting to get into, or your more analytics users getting into things like React and Vue, because the JavaScript people, I feel like, pretty much burn their user interface methodologies to the ground at least every 2 to 3 years and create new ones. So there's a big learning curve there that people who are more in the analytics space may or may not want to actually get into. So RGA and Domino, which has helped us to solve some of these, we installed Domino in 2019, and that has been going really well. We planned it out quite we did serendipity, right before COVID, we got Domino installed and up and running, and that made our shift to remote work very helpful, because we were in a very traditional sort of office setting. We would just pick up a laptop, go work with somebody else. We're also global, though. Like my team, I've got everybody in North America now, but more and more people in the East time zone, and then the core team is in the Central time zone, and definitely spanning national borders there as well. We did do a build versus buy, because we looked at Domino and a number of its competitors, and there were definitely some within RGA. It's like, this is basically just Jupyter Hub. Just install Jupyter Hub, maybe throw Kubernetes into there so that you've got some orchestration among the different types. And that's how a lot of these build versus buy. Oh, it's pretty simple. We can basically just build that. And one of the favorite things that a manager of mine back when I was in IT used to often say is, a Corvette does seem expensive until you try to actually build one from scratch. So it's being able to buy something that already has a lot of the orchestration there, and we don't have to figure out exactly how we're going to deal with getting the RGA single sign-on into Jupyter Hub. And then, great, Jupyter Hub. What about the R users? What about the users that prefer Jupyter Lab and other things like that? And Domino has really given us kind of a standardized deployment methodology. So very often I would have an analytics person, a data scientist, an actuary. When you get your data, they are going to build the model. They have their data. They're going to use whatever tool they want to of their choice. They're going to do it maybe in R. They're going to maybe do it in Python. More and more, most of what we're doing is in Python. And they will create the system trained on all of the data that's been loaded into a Domino data set. Before that, it was maybe mapped on a drive, and they developed it actually on their laptop, which had some definite control issues that Domino helped us to get around. And then we would be ready to give that to IT. And before Domino, we would basically just meet with IT, and because we don't have access to deploy something beyond our firewall, because often we're having clients connect into this, and there's a lot of security ramifications there that just the procedure that we currently deal with, IT is the one who controls that external publication and all the pen testing and all the other stuff that goes with it. We would deal with, at that point, many different approaches, because we're a global organization. So one group might want to do it. Some groups would want to rewrite the whole thing into JavaScript. And the machine learning, we can just do that from first principles in JavaScript, or find a compatible library, retrain the model maybe, although a lot of the machine learning models do have now binary compatible versions in JavaScript, but that becomes difficult. Some want to basically just take the entire dependencies, get that basically into something cloud native, like a Lambda function. Some want to do it more like a Fargate, where you actually have an array of VMs launched to do that on Kubernetes. So what Domino gave us was very much a standardized way that we can deploy these models completely wrapped up. So it's now a RESTful web service. How does the inside of it work? Well, that doesn't matter. It could be R, it could be Python, it could be anything. And that gives us that solved a lot of discussions. We can now just hand it off to IT in much the same way that I could bring, a microwave into this room, plug it into the wall, so long as that contract is observed, and the contract there is that Docker image. The internal workings does not matter. And then we use Domino's dependency management to keep track of what Python libraries we've used and other things there. We're currently working on trying to get more to serverless so that we can use these Lambda functions, and we're using, there is Docker, and there is a way, we're working with Domino to, we came up with a pretty good technique of how to still take that same Domino engineered model Docker image and basically give that to IT. And one thing I do like about Domino, there's not much proprietary in there at all. When we were evaluating Domino versus some of their competitors, at the top of the Python code, how much import name of vendor dot blah 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 is there, because when I was looking at bringing Domino into the organization, definitely you want to look at the marriage of how we're going to get the contracts, how we're going to get everything set up, but you also want to look at the divorce. What would it look like to potentially remove this, and how much proprietary tooling is really in there? And the Docker images, all that's all just standard. They would continue running exported just like they are now. We can build them from first principles in Jenkins if we so desire. In the GUI and app development, that's always been a tricky one. Just simple dashboarding, usually using Streamlit, using other tools like that. The analytics users can produce some really amazing, compelling applications that we can then deploy into Domino, and Domino is handling that. Because if you just launch Shiny R, you're going to have you'll have an address, but it's WSTL, JHeaton, whatever it is at RGA. It's an internal address. And we did have sometimes people like accessing internal computers through. So basically, I don't know, I would tell somebody, okay, I've got the Shiny app running on my laptop or on my desktop, because when we were in the office, some of us had desktops and we would leave those running. And that becomes just a nightmare. And COVID would have completely destroyed that anyway, because if I leave my desktop running, especially something's going to reboot it, or they're going to cycle the power in the building, and then that's gone. So Domino, giving us the ability to launch those persistent servers in Flask and these others, has let us create some really quick proof of concepts that we can then, as they mature and they start to get more and more multi-user and they start to get more and more transactional, then we can start to work with IT, software engineers, to really get the engineering side of that actually set up. So my 5 points. I just picked 5 things that I thought was particularly kind of different between software engineering and data science. So data science is not really, I think you can move between the 2 spheres, and we've had people, I'm certainly an example of moving from software engineering more into the analytics side, and now I lead a team doing that. Oops, okay. So, and if you look at the 2 words, science and engineering, and to borrow on one of the slides that I saw in one of the keynotes, science is, in general, not just data science, any science, is the proving you can do it, and not really dealing with so much the scalability of what you're dealing with. The Wright Flyer, for example, that was shown by the keynote. It's this little tiny airplane that was aloft for, I believe, less than a minute. And I believe after it landed, it was not ready to go up again. It could carry 1 person. I think the keynote speaker said, and maybe your dog. I don't know about that. I don't think we had PETA yet at that point. So that is basically proving that you can actually do it. From an engineering standpoint, from a scalability standpoint, the Wright Flyer is absolutely horrible. you would have to, it's not really practical for anything, but it proved that something that we had never done previously could actually be done. And that's an area where I do find software engineers and the data scientists somewhat at odds. The software engineers, I just want to test the Wright Flyer. They want to build the airport, get the factory built to build the Wright Flyers, and let's just see if this thing even gets into the air first, before we do all the rigor of having a battery of unit tests, integration tests, all this Jenkins pipelines and 3 levels of escalation, all these other various things, when this might well be a throwaway in a month if the client puts it into their pipeline and we're just not getting the results or the lift that we were expecting. And then we might go in and re-architect the entire thing, use a different modeling approach. So engineering or software engineering does that at scale. I had a similar slide to the keynote on another presentation where I showed it basically evolved to, I don't know, like an aircraft carrier, which is or a rocket, which is sort of the ultimate in flight. Those are the heavily engineered, very reliable systems. Now we at RGA often divide things into POC versus an MVP versus a production application. So the POC, that's the earliest stage. That's like the Wright Flyer. And the real trick there is figuring out how you can scale back what you ultimately want to have. You can't have the airplane with one wing, because that's not going to prove anything. But you also don't need the in-flight oxygen and other things that you can strip off. So the POC, proof of concept, we define that as something that we'll work together, we'll collaborate with IT very quickly in the beginning, but then we'll start to build that POC and we're going to see what that looks like. We try to time box it because we also have another term that we sometimes use is common law production. That means it was never really set up to be a production system, but it's been there so long that we just, I don't know, by common law, we just decide now it is a production system. And those usually end up with significant rewrites, and now they've grown to the sprawling thing. So we try to very much avoid that. Then we get into the MVP, which is where we have a lot more interaction with IT, where now we're going to build a minimally viable product. This will be a formal production system. This will allow users to be dependent on it. We're now we're a global organization, so one of the first things when you create a true production grade system is if you've got UK users using this, what happens when first thing their morning after a deploy, something's not coming up? How do we deal with that? And particularly external, when we're putting a model out that some of our clients, some of the direct writer insurers might be using, they're from all over the world, and language sometimes becomes potentially an issue there. So we work with IT to establish the SLAs with our external clients, what can be expected, what's legal, what we're doing there. And then finally, once it's in the production system, now it's truly one of our, you can call the help desk, you can, when it's down, disaster recovery, like if a major part of our network is down, is this system going to still be available? Because this is now something that multiple users are dependent on, and RGA finance income is potentially connected to. So as they grow through that, now Domino itself is a production system, so a lot of the stuff that's running in there is fine. But when they grow out of that to beyond just a simple dashboard, that these models are either integrating into RGA production systems, or that they are now becoming systems of their own. And this is how we're able to innovate at scale. Often the things that, like a very common pitfall that I've seen some of the models, is that was one of my first jobs when I came into the analytics group, was getting, we had all these neat models that ran in Jupyter Hub or Jupyter notebooks on laptops back when they began. And my job was to get those behind a RESTful API when I first came out of IT. And one of the first ones that I dealt with is the data scientist had created the typical like 80% it was trained on, 10% was what it was held back on, and that holdout set when it was validate, or when it was scoring it, I noticed that it took about 10 minutes to score the to score the data, because they never ran this in a real-time sort of situation. So I thought, okay, that's interesting. Let me take it back to just one record. So I basically truncated the pandas data frame so that there's now just one record. And I ran it again, and it was also 10 minutes. So, okay, for this to be a real-time system, we now have then you have to figure out, okay, how much of that is warm-up? Like if we're loading these models into the RAM, how much of that are we going to now need to keep into memories? Those are things that the data scientist, that at least the way that we divide analytics away, that's more of an engineering challenge that they didn't necessarily think of. I don't know that the data scientist was even, I don't know that we were even aware, was this going to be ran in batch, where it wouldn't have mattered? We just throw compute at it, parallelize it. Or was it going to be ran behind an API where we want this to be completely nearly synchronous, where you get the result back. Point number 2, I say hackathon versus SDLC. I'm being a little bit clickbaity there, but when I was in IT as a software engineer, we had a lot fewer of, at least in the way that RGA is set up, we had a lot fewer actual projects. You had one, like I started initially working on our retrocession module. So all of the business in RGA, as it comes in, we don't keep all of that business. We retrocede that out just like the direct writers do. Sometimes for tax reasons, sometimes for reasons that is very proprietary to the way that RGA does business. So I wrote all of that software. And that's a system that has a long lifespan. It was going 5+ years when I moved over into the data science group. So you've got these very mature sort of systems that you can build all the infrastructure and the testing around it. They're very well defined. It's going to usually all be in one programming language. You're not necessarily, the IT projects, you tend to standardize your programming languages and the tools. The data science ones, typically, you're going to let the data scientist work with, if they like Dask over Spark, you're going to probably let them use Dask. If they like R over Python, you're going to probably let them work with that. So in the IT, the software engineering world, we've got these systems like the retrocession module. Well, if that quits working and it doesn't come up one morning, we're going to lose money. We have backup contingencies in place, but largely it's going to have a material impact on us. So those are very regimented. That's a system very, very well known. The data science groups, we have clients coming in. Can you create we've got all these annuities, and we're wondering if you could build a propensity model to tell us how likely some of these annuitants would be to buy life insurance. So we very quickly in the data science group build that. That may or may not be something that we do that we're going to keep around long term. So one software engineer that I was working with, he made the comment that I thought was kind of, it's like, you guys are just like a hackathon a week. You're just building this thing by the seat of your pants, speed of light. Uh, have you even put this through a formal technology review console? Have you done all of this this litany of I don't know, fill the form out in triplicate, get all the necessary approvals. So I did, and it's like, yeah, I do get that. It is a bit like a hackathon a week, because we're really just trying to prove, again, will this thing get airborne? Is there any lift? Fail fast and pivot is very much what we're very much trying to do. We'll get the rigor in there later if this looks like it's something that will actually fly. And as these things come into the true production systems, that's where you need very much to work with IT to make sure we understand the scalability. We had a data science group, not too familiar with the engineering, implemented. We needed OCR capabilities, so they used a off-the-shelf package called Tesseract, and Tesseract is great. But, and okay, how will we actually then, the underwriting group is going to send us in all of these policies, many an hour. How are we going to actually deal with being able to respond to them quick enough? Oh, that's easy. We'll use Spark. So we set up this Spark grid that basically had all these Tesseracts up and running. And the PDFs would come in, and they would be processed, and then we could, and we built this all very quickly, and it worked really well. The underwriters liked it. The only problem that we really had with this, and this is an engineering problem, is if you look at the demand of the day, it's kind of a skewed bell curve of not very much at first, and then you have the surge, and then it goes down. Well, how all those Spark nodes, how many of those do you keep up and running, and how do you pull them back down? And now you're in a very complex demand scaling engineering sort of solution. And then, as we learned, or you can just use AWS Textract, and all the scaling becomes a cloud native problem. So those are some of the things where, when we worked together, we were able to do the very quick POCs, but then when we had to take these things really to production, we were able to figure out very scalable ways to do that. Point 3, standardization and specialization. I talked about this a little bit, but in IT projects, at least when I was on them, it's like, okay, this is in Java, or this is in Node.js, this is in whatever. If you have some new guy on the team that comes in and he's like, I'm really a Python coder. I know the rest of this is in Node.js. Why don't we just make my part a web service? Nah, he'll be beat into submission pretty quickly. So that is very much the approach. Now, if you're a React full stack sort of software developer, and you're coming into a company that's using Vue primarily, I don't know, maybe you go find another next job. But in data science, in many of the companies, many of our peer companies I worked with as well, that's not at all the case. If I suddenly told my entire team that we are standardizing away from Python onto SAS or something like that, my next call better be to my recruiter, because I'm going to have some work to do. You'll lose people. They're going to use the tools that they think gives them not just the job stability in their current job, but through their data science careers at future companies. The data scientists, so like I said, will utilize very different languages and technologies. They'll use Spark. They'll use Dask. They'll use. I really had not worked with or dealt much with Ray, and that's why I go to conferences like this. I'm like, okay, let's probably want to see what options that has, because potentially we'll we'll perhaps be evaluating that as a tool in the future. And I see it's already supported in Domino quite well. Point 4, just exploratory data analysis versus ETL. Now, RGA is moving towards a data fabric, and this should help some of this easily, but data scientists must often bring diverse and evolving data sets together. So we'll have some data sitting in SQL Server, we'll have some other data sitting in Oracle, because we have all of these various platforms at play. And often the data scientist just, again, wants to see if the right flyer is going to get into the air. And we're talking about, okay, how can I just get this together for my research project? The IT strategy is more, oh, we need a formalized ETL pipeline. Get this built together so that it's scalable and it can work in the future. So this is another area where we've often had to have just some discussions of how to really deal with that in the data science group. Or sometimes various of the analytics folks simply don't want to retool. They know how to use SQL Server. They know how to use Oracle, PLSQL. They know these particular tools, and they don't necessarily want to upgrade to Vertica only to be told to upgrade to Snowflake about a year later. So those are some of the back and forth that I particularly see on these. Now, in the theory, the data fabric, and that's another one of those regular expressions of data fabric, data lakehouse, data ocean. We'll eventually have an ocean planet. But those are some of in theory, you should be able to get one common sort of way of accessing the data so that you're able to use them in the tool of your choice, but maintain the lineage of where that data has gone. Because a lot of our data has PII, very sensitive health data, so we've got to be very, very careful. We can't just let the data scientist load it onto a laptop, fly into LaGuardia, and leave it at Starbucks. So it's lots of concerns certainly there. And then point 5, this one I find quite interesting, is just the reproducibility versus maintenance. So in IT, we do a lot of static code analysis, and this is great. You can have programs run and analyze your code, and they flag things. So we've got something, I won't name the vendor, but it goes right into our Git repository, and it gives you these little nasty grams if there's vulnerabilities in the code, other things like that. And a large formal IT project like the retrocession system that I mentioned, this is great. You want to keep these up to date on the vulnerabilities, and these are deployed out on the internet. So your attack vector is huge. There's other data, there's other processes interacting with it, and that sort of thing. Whereas if you're a data science, one of these hackathons, so to speak, many of our data models that we've worked on, we'll have a case where maybe we've done 10 or so projects. They're sitting in there in the code repository. We don't want to be updating each of those to when basically one of the Python libraries now has a vulnerability. And often the vulnerability is not something that's going to happen anyway. Like if you, for example, if there's a way that by me being a bonehead, I can cause TensorFlow or PyTorch to core dump, to crash, me doing something completely stupid, that gets raised often as a level 1 severity. The reason for that is there's a way that you can make that thing core dump. If that's running on, say, a Kubernetes cluster, something like that, the attacker, the bad agent, can maybe find some way to cause that core dump, and it makes an awesome denial of service attack because you keep sending that thing in, and all of your pods are going to keep crashing, and you'll chew through a ton of resources. But very often, the data science project that was using that is something that we haven't touched in 3 years. We may need to rerun it later for regulators, and we want to run it exactly as it was ran back in that day, and it's just ran as a batch job. There's no attack vector hardly even to it. It's not going to, the fact that some weird anomaly could cause it to core dump is just doesn't particularly matter. And more so with TensorFlow than PyTorch, those upgrades often have breaking changes that you have to fix and adjust. And if we have the data engineer fixing all of those breaking changes, you're potentially introducing other changes that there's just not a lot of return on investment of keeping all these old projects constantly up to date. So that's kind of a balance that we've worked on as far as just dealing with what archive software looks like versus stuff that we're actively keeping in production. And then where we're going from here, we do have an enterprise data strategy and a data fabric that we're working out that will hopefully bridge some of our data access issues. We're really trying to minimize local compute, because if you have a software or a data scientist that has installed all sorts of libraries and Python onto their local computer, that is active code, potentially with vulnerabilities sitting there. Whereas in Domino, if you don't have if a vulnerability creeps in and you don't do anything about it, largely that's a line for a library with a version number off in a Docker file. It's completely inert. It's most likely not going to cause any particular problem unless you spin up that whole instance. So you don't have actual. And then large language models, we've developed kind of a center of excellence around that, and we're trying to figure that out. We're looking at them for a lot of different things. We deal with a lot of very unstructured data, so we are looking at them. Some of our most promising projects is essentially like regular expressions on steroids. Is I can tell it, extract a birth date from this text, and it's not just looking for something that matches a date. It knows all the other junk dates. If we engineer our prompt properly, it knows that, okay, policy start date, that is not referring to a birth date. And this lets us go in and find that. And then we're also evaluating using them as virtual assistants. Just really, they can write code really, really well, except for the times that they don't. So we're looking into that and looking at really what will that look like in terms of, like, will we be putting prompts into the source control? And another thing I find fascinating on the LLMs, we often tell it to write in Python, or I just wonder if in the future there'll be programming languages specifically for the LLMs. Because things like Python, Node.js, we put a lot of syntax sugar on it. I mean, basically, C is Turing complete. So I don't know, I haven't seen a study of that yet, but it would be interesting in terms of if the LLM is not using a third-party library, maybe C is actually one of the more optimal ones because it doesn't have all the syntax sugar of dynamic assignments, duck typing, all these things that really make these programmers nice for human beings to actually interact with. We're dealing with data sovereignty with Domino so that we can actually run the data and compute where it needs to actually run. If the EU doesn't want it run in, say, United States. And then GPUs we're looking at. We did very much a march to the cloud, getting everything into the cloud, and now more and more at these kind of conferences, I'm seeing, oh, this is how you do a hybrid cloud, because the GPUs are so expensive that you probably don't want to rent those from your friendly neighborhood cloud provider if you're running something truly at LLM scale. All right, that is my presentation. If there's any questions, I would be glad to try to answer them.